I'm here to answer your questions on assignment 55. So the ones that asked it, good job. Let's get right to it. The first question that was asked was about those Teepee Cupcakes. They said you needed to make 2 dozen of the cupcakes and that the ice cream cones that you were using to make them were 6 inches tall. It also said that the batter was only going to be filled to within 1 inch of that level. So for that, we're thinking about the batter coming up in this ice cream cone cup only to be the 5-inch mark. It said also in the description that there was 2 inches across where the batter was in there, and gave us a little bit of extra information that a cup of batter was 14.4 cubic inches. So we need to know the volume of the batter in one of these ice cream cone cupcake things. So we use our volume formula. Our radius in this, though, is 1. It said that it was 2 inches across. All the way across would be a diameter, so 1. Plug that in. And for 1 cupcake, that gives us 5 times 1 times 1/3, which is 5/3 pi for just one of the cupcakes. But we need to make 2 dozen cupcakes. So since we're making 2 dozen cupcakes, we need to multiply the volume of batter for 1 times 24, which gives us 40 pi cubic inches, which when you put it in the calculator and you do 40 times pi, you get 125.7 cubic inches. Well, that's great, but you're measuring your cupcake batter in cups and you need to know how much to make. So you need to divide that by 14.4 because there's 14.4 cubic inches in each cup. So what that'll leave you with is how many cups you need, which is 8.7 cups of cupcake batter. And let's move on. Question number 23 was also asked, and I drew a picture to go right along with it because it was very verbal. And sometimes drawing a picture, mental picture, can help. It said you had a cube, and we know that cubes have all equal sides, and there was a cone in it so that one of the faces held the circle and then the actual point of the cone went all the way to the other side of the cube. So they also gave us the bit of information that it was 729 cubic inches was the volume of the cube. What we want to do with that is we want to find out how much each one of the side lengths is, because that's going to be needed to help us to find the volume of the cone, sorry, not cylinder, of the cone that's in there. Okay, so when we find out that each side is 9, that's going to give us some information for our cone. Our volume formula for a cone is 1/3 pi r squared h, just like we knew from the last problem. And so when we take 1/3 pi, radius is going to be 9 because our length across this cone across the top is the same as the length of one of the sides. And so since it's 9 all the way across, it's 4.5 to the middle, and we need the radius for this formula. And then the height is also 9 because it's basically inscribed inside of this cube. So it's 9 inches high, and you plug that in, put that in a calculator, 1/3 times pi times 4.5 squared, and get about 190.85. All right, this problem, just so that you get the idea of this, we've already talked about the volume of a cone formula. And so in this problem, they give you basically the task of finding out the area, the volume of this blue shaded portion. But in order to do that, you'll use your volume of a cone formula for this big cone. And then you're going to subtract out this small little white cone. So you'd find the 2 volumes, the volume of the big one minus the volume of the small one, and that'll give you the volume of this blue shaded in piece right there. So that should be a good hint to get you going, especially since we know that the volume of the cone is actually 1/3 pi r squared h. So you would use that formula twice. You did have to do a little bit of thinking through in figuring out how tall the cone was, the big cone, because they were given that it was 6 and 6, so together that makes 12 for the height of the tall cone. They gave you the height of the small cone, and then the radii, the other numbers that you need were also given, so that should be enough to get you going on that problem. Number 29, a couple of you had asked about this one. And this is very similar to that cone problem I was just talking about, but we hadn't reviewed the pyramid formula. Okay, we have a big pyramid and we have a small pyramid. Okay, if you take the large pyramid and you subtract out the small pyramid, that's going to give you this blue shaded in area. Now, they didn't give it to you in this form. They gave it, once again, as a verbal problem dealing with a building that was pyramid shaped with a top spire that wasn't usable. So they wanted the usable volume. So you take the volume of the whole entire building, which they gave you the 175 and they gave you the 853. But they tried to be tricky about it and they put it throughout the problem. So you had to figure out, okay, first of all, what was the sides of this base? Okay, now wait, I have an H and I have a B, so what's with the 175 squared? It said it's had a square base, and it gave you that one length of one side was 175. So if you have 175 this way and 175 this way, the area of that base is going to be 175 squared. And then the height was given, and then you do that math. Then for the small one, the little piece up top, they gave you that 50 was the length of one of the sides. So the area of this little square is 50 squared, and they said that it was 210 feet high. So this height is the whole height all the way from the bottom all the way to the tip top. So once you found this volume and this volume, you need to subtract those two numbers. And once you've subtracted them, it gives you the usable space in the building. All right, so it's just like the cone problem I just talked about, but there was a lot of words to be able to consider in that to be able to figure it out, what they gave you. All right, then finally, these last problems here. It asked you what happens if R is doubled, what happens to the total volume? So let's think about it for a minute. If this is now 2 times as much, okay, so instead of being R squared, it's 2 times a value squared. Sorry about that. So we have 2 times R, and this is the part that's squared, 2 times the original R. So what happens when you square this original part, 2R, because this part got doubled, is we get 4 to replace the R squared, so the whole quantity is 4 times bigger than the original quantity. All right? And if you needed to convince yourself, you could give yourself a couple of examples with numbers in there for R, and you will always find that the total volume turns out to be 4 times as much, because the only difference in the formulas is that this is now 4 times the original R squared before it got doubled. Now this one involves a picture in your book, so hopefully you've taken a look at this. And it was a tricky question because you haven't seen it for a while, but AC has to be 8 in this one because AG is 8. If you're looking on your page 434 of your assignment. Those two are equal. They're the same distance from the center because are equal, and it tells you that the lines are perpendicular. So all that together, since the chords in the circle are equal, that means that those two pieces are equal distance from the center. So that's why AC has to match the other one, the other number, which is also 8, coming from the center of the circle where A is the center. And then finally we have this one. Okay, on this problem, you're supposed to draw tangents to the circle starting from B. So if you start from point B and we sketch in our tangents, the tangents have to hit at just one point. So you had a circle C and you just take a ruler and draw them in. The directions did say construct, but we had so much to do in this course that the construction lesson didn't get done. Sketch them in. Take a ruler, you start from B and you go across here. Take a ruler, start from B and go across here so it hits at just one point. That's it. And thanks for asking your questions and being diligent in your studies. And I hope you have a good rest of your day. God bless.